next. So you can also use the arc length formula for a function of y, f of y, as long as f prime of y is continuous on the closed interval a to b. So your arc length is equal to integral from a to b of the square root of 1 plus f prime of y all squared, and the integral will be with respect to y, so dy. In the next example, find the arc length of this function from y is equal to 1 to y is equal to 5. So in this case, we have a function of y, and we'll be integrating with respect to y. We are looking for the arc length, so we're looking for the length of the function from y is equal to 1 to y is equal to 5. So we can use the arc length formula with respect to y. So we'll write down x as a function of y. Y minus 1 is cubed and square rooted, so we'll rewrite it y minus 1 to the power 3 over 2. So we took the derivative using the chain rule. U to the 3 over 2 is 3 over 2 u to the 1/2, and the derivative inside is just 1 with respect to y. So next we can square x prime. So 3 over 2 squared will be 9 over 4, and the square and the square root will cancel out, so we'll just have y minus 1. Next we can plug it into the arc length formula. So the integral is going from 1 to 5, square root of 1 plus x prime squared, which is 9 over 4 times y minus 1. So here on the right, I'll just multiply out what's inside the square root. So we have 1 plus 9 over 4y minus 9 over 4. If we add 4 over 4 minus 9 over 4, we'll get minus 5 over 4. And then I'll take out 1/4 in the front. So we have 1/4 times 9y minus 5. So we have integral 1 to 5, square root of 1/4 times 9y minus 5 with respect to y. So the square root of 1/4, I just took it out in the front as 1/2. And now we can solve the integral using substitution. U is 9y minus 5. Du is 9 dy, so we will end up dividing by 9. So just on the side, we'll do this integral without the limits first. Square root 9y minus 5 we will replace with square root u, which is u to the 1/2. Then dy will become du over 9, which is written here. So take the antiderivative of u to the 1/2. It will be u to the 3 over 2 divided by 3 over 2, or multiplied by 2 over 3, with the constant 1 over 9 plus c. Now we'll put it back in y. So we have 2 over 27, 9y minus 5 to the power 3 over 2 plus c. So now the integral becomes the 1/2 times 2 over 27, 9y minus 5 to the power 3 over 2, and it kept the original limits 1 to 5 and y. Alternatively, you could have done the definite integral in terms of u, but then you would just remember to change the limits of integration into u as well. Next, we can just evaluate the integral. So 2 and 2 cancel. In the front, we have 1 over 27. At upper limit 5, it's 40 to the power 3 over 2. And at lower limit 1, it's 4 to the power 3 over 2. Just to simplify it, since 40 is 4 times 10, 40 to the power 3 over 2 will be 4 to the power 3 over 2 times 10 to the power 3 over 2. In this case, you can take out a factor of 4 to the power 3 over 2 from both terms, which will make it look nicer. So the square root of 4 is 2, and 2 cubed is 8. So that means we can factor out 8 in the front. So the integral becomes 8 over 27 times 10 to the power 3 over 2 minus 1 units. So you can check that the arc length is around 9.07 units. Next, we will consider what the following have in common: spiderwebs, the St. Louis Gateway Arch, a bubble formed by 2 circular wires, and hanging cables. This common hanging shape is called a catenary, and it's modeled using the hyperbolic cosine function, cosh of x, which is another way of writing e to the x plus e to the minus x over 2. This shape looks like a parabola, but it's a different function. You can make this hanging catenary shape yourself by holding a chain or rope between your hands. In the next example, a cable is hanging between 2 poles of equal height that are 20 feet apart. The shape of the hanging cable is a catenary and is given by this function. Y is equal to 5 times e to the x over 10 plus e to the minus x over 10, where x is in between minus 10 to 10. And the question is to find the length of the cable. So we can use the arc length formula and integrate from minus 10 to 10. So the derivative for e to the u will be e to the u prime. So we'll keep the constant 5 in the front. The derivative of e to the x over 10 will be 1 over 10 times e to the x over 10. And for the next term, the derivative of e to the minus x over 10 will be minus 1 over 10 times e to the minus x over 10. We can factor out 1 over 10 in the front. Then y prime will be 1/2 times e to the x over 10 minus e to the minus x over 10. To use the arclength formula, we have to square y prime, so we can square both factors, 1/2 squared and the other term squared. So 1/2 squared will be 1/4, and here for this term on the right, don't forget to FOIL it out. So you'll have 4 terms and you can simplify it. The first terms give e to the 2x over 10. The outer terms give minus e to the 0. The inner terms give minus e to the 0 as well. And the last terms will be e to the minus 2x over 10. So when we add up the like terms, we have e to the x over 5 minus 2 plus e to the minus x over 5. Y prime squared is 1/4 times e to the x over 5 minus 2 plus e to the minus x over 5. Next, we will plug it into the arclength formula. So we have the integral from minus 10 to 10, the square root of 1 plus y prime squared. So we can add the constant of 1 minus 1/2. That will give us 1/2 in the middle. In this case, it's possible to re-express the inside of the square root as a square. So the square root and square will cancel out, and then we can integrate it easily. So here on the side, the inside of the square root can be rewritten as e to the x over 10 over 2 plus e to the minus x over 10 over 2 all squared. So now we have square root square, so those will cancel out. And then we can solve the integral using a simple substitution. So first we took the constant 1/2 in the front from both of the terms. For the integral e to the x over 10, we can use the substitution u is x over 10. Then du will be dx over 10. So we can replace dx with 10 du. So the integral will become 10 e to the x over 10 plus c. For the other term, it's very similar. We can multiply by minus 10 for the integral. You don't have to do this if you don't want to, but here, since the function is even, so it's symmetrical across the y-axis, f of minus x is equal to f of x. So since in our integral we're integrating from minus 10 to 10, and it's symmetrical over the y-axis, this would be the same as integrating from 0 to 10 and doubling up on the integral. So using the fact that it's even, we'll have 2 times the integral from 0 to 10 of e to the x over 10 plus e to the minus x over 10. The 2 and the 1/2 will cancel, and then we have 10 e to the x over 10 minus 10 times e to the minus x over 10 from 0 to 10. So we'll have the upper limit at 10 minus the lower limit at 0. So you can check that the arc length will be 10 times e minus 1 over e feet, which is around 23.5 feet.